Alright, this is Mr. Gillum, and today we're going to talk about triangle inequalities. So we've done a little bit on inequalities before in the past, and when I say inequality, what I'm talking about is a less than or greater than sign. Okay, we're going to figure out what the possible lengths of a triangle are today. Alright, this is the blank of any two sides of a triangle must be blank than the third side. Now we discovered this in class when we were trying to draw a triangle with the certain side lengths, and it was never going to work. I think it was like 3, 5, and 10 were the side lengths in class, and we just couldn't make it work. No one could figure it out. Well, we figured out later that, well, 3 and 5 are never going to reach all the way across of 10. So we're going to say is the sum, that means addition, of any two sides of a triangle must be greater than, and that's where our first inequality sign, that's a greater than sign, must be greater than the third side. So the sum of any two sides of a triangle must be greater than the third side, or it's just not going to reach. Okay, so to check that, what we do is, if I'm given 3 lengths, before I start drawing, I can just check to see, well, let's find out. Is 4 plus 9 greater than 2? Is 9 plus 2 greater than 4? And is 2 plus 4 greater than 9? Well, I know that 13 is bigger than 2, so that's okay. I know 11 is bigger than 4, that's okay. I know 6 is not less than 9, so there's a problem. Not a triangle. Not possible, okay? Not a triangle. It won't reach 4 and 2. If you think about it, this is 9, this is 4, and this is 2. There's no way for me to reach all the way across 9 to get to both sides of the 9 centimeter side. So it's impossible. Okay, this is the work I'm going to expect you to show me whether it is or is not a triangle. Let's check number 2. Well, let's see here. Is 6 plus 9 greater than 4? Is 9 and 4 greater than 6? And is 4 and 6 greater than 9? Let's see here. Well, this makes 15, and that's bigger than 4. This makes 13. That's bigger than 6. This makes 10. That's bigger than 9. So yes, this is a triangle. Yes, it can form a triangle. Okay. Well, let's take a look at this last one here. 2 plus 4. Is that greater than 2? We know if 4 plus 2, is that greater than 2? And is 2 plus 2 greater than 4? Well, let's see here. 2 plus 4 is 6, and I know that's greater than 2, so that's fine. 4 plus 2 is 6, that's greater than 2, that's fine. Uh-oh. 2 plus 2 is not greater than 4. 4 is not greater than 4. So this is not going to work. We're going to be able to reach both sides, but we got to have just enough to where we can put, if we had like this 4 centimeter side and we had exactly 2 centimeters and 2 centimeters, 2 centimeters and 2 centimeters, there's no room for these when I start making this angle here. It's not going to quite reach in the middle. There's going to be a little gap if I try to make a triangle. So it has to be actually greater than 4. It can't be equal to 4. It has to be greater than, not equal to. Cannot be equal to. Okay, so not a triangle. Okay. So let's take a look at this next part, and here's where the fun begins. It says, when given two sides of a triangle and asked to find the possibilities for the length of the third side, you express your answer as an inequality. Okay, and so what these blanks here are for are just whatever numbers we need to put in. So there's going to be a number on this side of the inequality, and there's going to be a number on this side of the inequality. And what it means is, if I just had an example like 3 is less than x is less than 5, that would mean that the length of my last side would have to be somewhere in between 3 and 5. Okay, it's called a compound inequality. All right, so it's always a less than sign. It's never one side's going one way, one's going the other. It's always not like, it's never going to be like this. It's always going to be the smallest number is smaller than x, smaller than the next number. Okay, and so in this case, they give us a little different type of problem. It says, given the two side lengths, determine the lengths of the third side such that a triangle could be formed. So what I have here is I have a 5 centimeter side and a 9 centimeter side. And since I don't know the last side, I'm going to say that's x. All right, I'm going to set these up just like on the last page. I know that 5 plus 9 has to be bigger than x. I know that 9 plus x has to be bigger than 5. And I know that x plus 5 must be bigger than 9. All right, so what I have here is 3 inequalities. Let's simplify each one. So what I'm going to say is I have 14 is greater than x. And I'm going to solve this one. I'm going to say x is greater than negative 4. And I'm going to solve this one. X is greater than 4. Okay, so all these things put together we got to think about here. Let's just use a number line to visualize. And yes, I do want you to have this number line in your paper as well. I'm going to put 0 right there on my number line. The first inequality says 14 greater than x. Well, when I graph inequalities, I like the variable to be on the left-hand side. But 14 has to stay bigger. So instead of writing 14 is greater than x, I'm going to write x is smaller than 14. I'm going to flip it around. But notice how I changed the direction of the inequality when I did that. 14 has to remain bigger. So it has to open towards 14. So I'm going to go to 14, put a little dash there. And I know it has to be bigger than 14. So I'm going to open dot, and it has to be bigger than that. Oh, sorry, less than that. Almost made a mistake on the first example. It has to be less than that. So my first graph would look like that. My second graph, and I'm going to go ahead and do it on the same exact number line, would say x is greater than negative 4. Well, here's negative 4. So it would be greater than side this way. And finally, x is greater than 4. So I'll just put a little dash right there at 4. And all the numbers bigger than 4. So I have these 3 graphs here. The numbers that have to be, that x could be, are where the 3 graphs cross. So as you can see, only in between these 2 dashed lines are where the 3 lines intersect. So I have stuff on that one, and that one. Okay, so those 2 numbers are the numbers I want to use. Somewhere in between 4 and 14. So what I'm going to write my answer is, I'm going to say, it must be bigger than 4 and less than 14. That's what the last side has to be, somewhere in that range. All right. So we're going to graph each of those inequalities that we solved. We're going to find where all 3 of them share solutions. So here in between these numbers is where they all share solutions. Over here on this side, we only have 2 of them. We need all 3 lines to be lined up. Okay. So pause that if you need to. I'm going to erase that so I have a little more room to work on the next one. This time I'm going to leave myself a little more space. All right, here we go. So to find this third length, I don't really know what it is. I'm just going to call it x. I know that 2 plus 8 must be bigger than x. I know that 8 plus x must be bigger than 2. I know x plus 2 must be bigger than 8. All right, so I'm going to go and do some solving here. My first equation, what I'm actually going to have is 10 is greater than x, but really I like to have the x on the left-hand side. And I know that 10 is bigger than x, so I need to make sure that it stays that way in my inequality. On this one, what I would do is I'd subtract 8 from both sides. So in this case, x is greater than negative 6. And finally, I would solve this guy, and I would say x is greater than 6. Okay? Now, to figure out what numbers my triangles, my last length, has to be in between, I'm going to graph each of those inequalities. Just put 0 on the number line. And the first one, it says that x must be less than 10. So let's go ahead and put a 10 on there. And an open dot going to the left. Must be greater than negative 6. Okay, we can do that. And also greater than 6. And so now I'm just looking at my inequality graph here, and I'm just trying to figure out where all 3 lines intersect. So it looks to me like it's in between 6 and 10, where I have all 3 lines on top of each other. Over here there's only 2 lines, and over here there's only 2 lines. So anything between 6 and 10. So that's how I'm going to write my inequality, just like that. 6 is less than x is less than 10. Any number in between 6 and 10 will make this a triangle. All right, once again, I'm going to erase this so I have plenty of room to work on the last example. So if you need to pause it, go ahead and pause it right now. And finally, the last example. I have a 3 centimeter side and a 12 centimeter side, but we don't know what that last side could be. Now, it could be a lot of different things. So we need a range of numbers, okay? I know that the last side must be, 3 plus 12 must be bigger than the last side. I know 12 plus x must be bigger than 3. And I know that x plus 3 must be bigger than 12. I'm following the same pattern that I did on the last slide. Now I have some solving to do for my inequalities. If I just add my like terms here, I have 15 is greater than x, but I wouldn't really write it that way. I'd want to write x on the left-hand side. Notice how the open is it's going open towards 15. When I switch it around like that, I need to make sure it's still opening towards the 15. Over here, to solve, I'd subtract 12 from both sides. So I would know that x is greater than negative 9. And on this problem, I would subtract 3 from both sides. X is greater than 9. So now it's all that's left to do is just to find my range of numbers that the last side of the triangle could be. Okay? It must be less than 15. It must be greater than negative 9. And it must be greater than 9. So now I'm just looking for the intersection of all three lines of possible solutions. And it looks to me like we're in between 9 and 15. So that's literally what my answer is going to be. The last side has to be somewhere in between 9 and 15 because it has to meet all three qualifications. So that's what I would write for my solution. It has to be bigger than 9 but less than 15. Alright, so that's it for today. You now know how to find the length of the third side so that you could have an actual triangle.